impacts have been taken care of or considered. So let's move on to what are the different types of metrics that are used in common software development scenarios. So there are two types. One is the leading metrics. This is the area of focus in today's discussion. And the other is the lagging metrics, which we are more familiar with, like defect count and schedule variance, cost variance, and your earned value matrices, all those things. So what's the difference between these two, and why leading metrics is important? So leading metrics are basically the performance drivers. So these are the processes or the tools that are used to get the performance, whereas the lagging metrics are used to measure the outcomes. So using these performance drivers, the processes and tools, what we have delivered, those are measured in the lagging matrices. So leading matrix talks about how the outcomes will be achieved, whereas lagging talks about what are the outcomes that was achieved. So this is like looking at it after the job is done, and leading is like looking at it while we are doing it. So that gives us early warnings about being on track or moving away from track, producing more defects, more unit test defects, or the code complexity is such that it is likely to produce more defects. So those kind of matrices are produced at this stage. And on the other hand, at the lagging ones, we get to see the final performance. So what was the total number of defects, critical defects, the defect density, and all that. This is measured at the process level, whereas the lagging matrices are measured on the outcome. And the leading matrices can be used to make corrections now that can improve the end result. Whereas the lagging matrices, when you are getting those matrices, it is already too late. So it tells you how well it was performed or how poorly it was performed. So these are the causes. The leading metrics are the causes. So how well you are complying to the processes and whether you are following all the steps or you're taking shortcuts, that predicts what will be the effects on time, cost, quality, and of course customer satisfaction. This is one factor which is not often counted or measured, but it's very critical, because even if you deliver on time within the proper budget and with the proper quality, you may be actually not satisfying the customer because their requirements may have been slightly different, and your requirements management part, although you think it was right, it was not actually right, or the requirements has evolved over time which you could not capture and put into your software. So customer satisfaction is also an important thing that should be measured as a lagging matrix. So leading matrices are predictive and proactive, so they are done at the time of performing the work, whereas the lagging matrices are reactive, so you get the data and based on that either you can use it historically for doing estimation for future projects, or you can use it to pinpoint what was the cause for this failure. So some examples of leading matrices are like process compliance, requirement stability, or the opposite, basically requirements volatility, change request backlog. So what is the rate at which change requests are coming in, and how many change requests are still left, then the velocity and trends of the project. So these are leading matrices based on real-time current data, and if you keep track of these matrices and do the corrective actions properly, then it's bound to impact positively on the quality of what you're trying to produce. Whereas examples of lagging matrices are like the typical schedule metrics, cost metrics, and defect metrics. So what was the schedule variance and cost variance, these sort of matrices. And this is a very common comparison in the industry, that leading matrices are known to be the windshield of your car, and the lagging matrices are like the rear view mirror. So you cannot drive the car looking only at your rear view mirror. You need to look to the windshield. So if your windshield is covered with snow and your rear view mirror is showing you the perfect picture behind you, it's not making much sense. You need to look ahead so that you can drive your car, avoid the obstacles that are coming up. Okay, so let me give you some examples as to how these predictive matrices can